Jai Hind all. So today we are going to take up another application of the PN junction diode, that is voltage multiplier circuit. What is voltage multiplier circuit? Voltage multiplier circuit is nothing but a peak-to-peak detector which uses a small signal diode and it operates at a higher frequency signals. Voltage multiplier circuits, they are employed to maintain a relatively low voltage transformer peak voltage while stepping up the peak output voltage, which is 2 times, 3 times, 4 times or even more than the peak rectified voltage. So, it is possible with the help of voltage multiplier circuit that the rectifier, you can get the rectifier voltage of the transformer, which is the multiple of the voltage at the output. So, as the name suggests, it multiply the voltage which is available at the secondary winding of a transformer. So, it is possible to get 200 volt DC from 100 volt peak AC source using a voltage doubler and 400 volt DC from a quadrupler. So, quadrupler means which can give you the voltage that is 4 times of the voltage which is available. So, basically voltage multiplier can be converted into the voltage doubler circuit, voltage tripler, quadrupler or even more. So, depending upon that what type of circuit we want to design, we have to use a pair of a diode and a resistance. That means, if you would like to design a voltage doubler, then it requires 2 diodes and 2 capacitors. So, basically there are the it is consisting of the 2 components, that is the diode and the capacitor. So, a pair of diode and a capacitor will give you the multiple of the output voltages. So, if you are using two diodes and 2 capacitors, then we are going to get a voltage that will be double, that will twice of the input voltage which is applying at the input terminal. Similarly, if you are using the 3 diodes and the 3 capacitors, then we get the tripler circuits. That means the output which is available, that will be 3 times and so on and so forth. So, every time you want to keep multiplying the voltage, then we have to use an additional pair of the diode and the capacitor. So, this circuit consisting of only, if we talk about the voltage doubler circuit, so voltage doubler circuit is the voltage multiplier and which has a voltage multiplication of the factor of 2. So, it consisting of only 2 diodes and 2 capacitors and an oscillating input voltage, AC input voltage. So, this simply diode capacitor, this circuit pumps, this circuit gives a DC output voltage which is equal to peak to peak value of the sinusoidal. So, in other words, we can say that double the peak voltage value because diode and capacitor, they work together to effectively double the given voltage signal. So, here is the circuit. So, basically voltage doubler circuit can be categorized into 2 or it can be classified into 2 parts, that is half wave voltage doubler and full wave voltage doubler. And full wave voltage doubler. Full wave voltage doubler. So, this is the circuit diagram of full wave, half wave voltage doubler, which is consisting of 2 capacitors and 2 diodes. So, in this circuit, we are giving the input signal which is available at the secondary winding of the transformer. So, if this is the input which is available between the terminal A and B, and suppose this voltage peak value is Vm and this is minus Vm. So, peak to peak value is twice of Vm. So, during the first half cycle, terminal A will be at positive potential and terminal B will be at negative potential. So, because initially we assume that all the capacitors are fully discharged. So, during the first half cycle, first positive half cycle, this negative terminal makes the diode D1 forward bias. So, when your diode D1 is forward bias and diode D2 will be in the non-conducting state, because initially all the capacitors are in a fully discharged position. So, during that cycle 0 to T1, the current will be flowing in this loop. So, because current is flowing in the clockwise direction, so that the polarity across this plate will be plus and minus, because we know that the current flows from higher potential to lower potential, and that is the reason that the voltage which is appearing across this plate will be plus and minus. Let us say the voltage up to which this capacitor has been charged is equal to Vc. So, during the first half cycle, if we write the KVL across this first loop, it will be Vm minus Vc is equal to 0. So, this will give the Vc is equal to Vm. So, the capacitor will be charged up to the value Vm. So, that is why here it is written Vm. So, capacitor is charged to the value that is equal to Vm. Now, during the negative half cycle, that is T1 to T2 time period, terminal A will be at negative potential and B will be at positive potential, and capacitor Vc1 is charged up to the value Vm with the polarity marked plus and minus across the plate. So, we can see that this negative potential and this negative potential will make diode D1 reverse bias. So, it will be open circuit and diode D2 will be forward bias. So, it will be short circuit. So, because of that, your current will start again flowing in the circuit. So, let us mark this as the, again let us assume that the current is flowing in the clockwise direction. So, if current is clockwise, then again the potential which is appearing across this plate will be plus and minus. So, if we again write the KVL for the second loop, then it will be minus of Vi, this is basically Vi, minus Vc1 minus V0 is equal to 0. The voltage which is appearing across this is V0. So, V0 comes out to be, Vi is nothing but Vm. So, V0 is equal to minus of Vm plus Vc. Vc is again equal to Vm. Here we can see. So, V0 will be equal to minus of twice Vm. So, what does this negative sign signifies? That the direction of current should be reverse of what we have taken in the circuit. So, that is the reason we have to change the polarity across the capacitor. So, here across the capacitor we get the output voltage that will be equal to twice of Vm, rather minus twice of Vm. So, that is why this will be at negative potential and this plate will be at positive potential. So, this is how we get the output voltage across the second capacitor, that is Vc2. So, after one complete input cycle, we are going to get the output voltage which is double of the peak voltage which is appearing across the secondary of the transformer. Second type of the half wave voltage doubler is the full wave voltage doubler. So, full wave voltage doubler is again because it is a doubler circuit. So, again we are going to use the 2 diodes and the 2 capacitor, but the circuit is slightly different. So, here we can see that this is the circuit. So, first diode D1 is connected with the capacitor C1 and also a diode D2 is connected from this terminal, and the direction of the D2 is reverse of the direction of the D1, and one more capacitor is connected. So, these 2 capacitors are connected in series in case of the full wave voltage doubler circuit. So, again the voltage which is appearing across the secondary winding of the transformer is given by, this is the input signal, this is Vm, this is minus of Vm. So, during the time period 0 to T1, terminal A will be at positive potential and B will be at negative potential. So, because of that, diode D2 will be non-conducting, whereas diode D1 will be conducting, because initially all the capacitors are in a discharge position, and this positive will make diode D1 as the forward bias and diode D2 as the reverse bias. So, this is open, whereas this is short circuit. So, now your current will start flowing in this loop in the clockwise direction. So, higher potential to lower potential. So, because of that current, your potential, the voltage, because of this current, direction of this current, the this plate will be at the higher potential and this plate will be at the lower potential. Now, let us write the KVL. So, it will be Vi minus of Vc1 is equal to 0. So, here Vi, value of Vi is nothing but the peak value of the Vi is Vm. So, keeping that value, placing here the value of Vi. So, Vc1 will be equal to Vm. Because this is the positive sign, here the sign of this capacitor voltage is positive. So, we will retain the sign which we have taken across this capacitor C1. Now, coming to the negative half cycle. So, during the negative half cycle, that is T1 to T2. During this cycle, terminal A will be at negative potential and B will be at positive potential. So, because of that, the diode will D1 will be reverse bias, because this positive, this positive, this positive and this negative will make diode D1 reverse bias. So, diode D1 will be reverse biased, whereas diode D2 will be forward biased. So, this is open. So, current will be flowing. Again, we are taking the loop clockwise. So, this is, let us say current I is flowing from here to here. This is flowing like this and this. So, because of that, this terminal will be of the C2 will be at the higher potential and the lower plate will be at the negative potential because of the direction of the current. So, let us say this capacitor is charged to the value Vc2. So, now write down the KVL in the second loop. So, it will be Vi minus Vc2 is equal to 0, where Vi is equal to Vm. So, Vc2 is equal to Vm. So, capacitor Vc1 is charged to the value Vm. Also, capacitor C2 is charged to the value Vm. and the potential and the polarity will remain same, because in both the cases the value is coming out to be positive. So, we will retain the polarity across the each of the capacitor. So, if you measure the voltage across the RL, that will be, it is nothing but these two voltages are in series. So, the net voltage will be equal to 2 Vm. So, the advantage of the full wave voltage doubler is that it allows higher voltage to create a which can be created from the lower voltage power source without the need of an expensive high voltage transformer, because with the help of voltage doubler it is possible to use a transformer with the lower step up ratio, and then it can be then it would be used for the in any the ordinary full wave supply were used. So, you can say that instead of using a very expensive transformer, a high voltage transformer, we can use a lower step up ratio transformer for the purpose of the voltage doubler circuit. If you compare the full wave rectifier and the half wave rectifier. So, what is the difference between the full wave rectifier and the half wave rectifier, and which one is more beneficial? So, you can say that in case of half wave rectifier, the output voltage is measured across a single capacitor. Half wave rectifier, in case of half wave voltage doubler, the voltage is measured across the single capacitor. So, the net output voltage which is measured across a single capacitor, which comes out twice of Vm. Whereas, if you measure the voltage in case of full wave voltage doubler, that appeared across the two capacitor. So, if we compare the two, then in case of half wave voltage doubler, we get the negative voltage, that is the minus of 2 Vm across the second capacitor, C2 capacitor, while in case of the full wave voltage doubler, this voltage is appearing across the two capacitors which are connected in series. So, because in case of the full wave voltage doubler, both the voltage is appearing across the two capacitors, and these two capacitors are in series. So, effective capacitance gets reduced, and which will give you the poor filtering effect. So, the disadvantage is that the in comparison to the half wave voltage doubler, full wave voltage doubler has more AC ripples. So, the better circuit is the half wave voltage doubler. Okay. So, now coming to the next circuit, that is voltage tripler circuit. So, voltage tripler circuit can be made with the help of the extension of the half wave voltage doubler. So, let us draw the voltage tripler. So, as the name says, voltage tripler. Tripler means it is consisting of three capacitors and the 3 diodes. So, 3 pair of diode and capacitors are required for the formation of the voltage tripler circuit, which is the voltage, which is nothing but the voltage multiplier circuit. So, here this is the transformer. So, here we are using a capacitor and the diode. So, here we can see that we are using the 3 diodes and 3 capacitors. So, this is comprising a circuit. This is consisting of the 3 diode and 3 circuits. So, this makes your the voltage tripler circuit. So, let us say this is C1, C2 and C3, D1, D2 and D3. The input signal which is appearing now during the time period 0 to T1. Initially, we assume that all the capacitors are fully discharged. So, because of that, during the first half cycle 0 to T1, terminal A is at positive potential and B at negative potential. This makes diode D1 forward biased. So, diode D1 will be in a conducting state, whereas D2 and D3 will remain in non-conducting state. So, because diode D1 is forward biased, so your current will start flowing in the first loop, and due to the selection of the current direction is clockwise. So, because of that, the first plate of the capacitor C1 at higher potential and the second plate is at lower potential, and let us say that this capacitor is charged up to the value Vc1. So, in order to find out the value of Vc1, we have to write KVL in the first loop. So, this is your Vi. So, I can say during 0 to T1 time period, your capacitor, this will be Vi minus Vc1 is equal to 0. So, Vc1 and Vi is nothing but Vm, the maximum value. So, capacitor will charge up to the maximum value Vm. So, Vc1 will be equal to Vm. So, because this value comes out to be the positive value, so we will retain the sign across the capacitor, that is plus and minus. Now, coming to the next half cycle, that is T1 to T2. So, during the time period T1 to T2, terminal A will be at negative potential and B will be at positive potential. So, we can see that this negative and this negative together will make the diode D1 reverse biased, whereas diode D2 will be forward biased, and because it is considered as ideal diode, so therefore, this will be short circuit, and diode D3 remains in the non-conducting state. So, now again we assume that current is flowing in the second loop shown by red pen, and here we can see that by writing the KVL for the second loop, we can write minus of Vi, because now the polarity is at negative potential, minus of Vi minus Vc1, and because of the direction of the current, this is plus and this is minus, let us say Vc2. So, minus Vc2 is equal to 0. Keeping values here, so minus of Vm minus Vm is equal to Vc2. So, Vc2 is nothing but minus of 2Vm. So, here we can see that in case of Vc2, we get the negative sign. This negative sign signifies that whatever direction of the current has been taken by us is reverse. So we have to change the sign across this capacitor. So let us change the sign across this capacitor. So instead of taking it as plus and minus, it has to be minus and plus, and the value will be 2 Vm. Now coming to the next half cycle, that is T2 to T3. T2 to T3. Now during this time period, terminal A will again at higher potential positive and B will be at negative potential, and this Vc1 is nothing but Vm with this sign, and Vc2 will be equal to twice of Vm with the sign represented by green pen. So if you look at carefully, we can see this Vm and this Vm will get cancelled, but the effect of these two voltages will get cancelled because of the sign notation, but this positive will make diode D1 reverse biased. Also this negative sign will make diode D2 also reverse biased, but this negative will make diode D3 forward biased. So now your current will take the path in the third loop. So this is your third loop. So again, because every time we are taking the direction of in the loop as the clockwise direction, so accordingly we will mark the polarity across the capacitor. So this capacitor will be at higher potential and this will be at negative potential, and let us say the voltage across the capacitor is Vc3. So now write down the KVL in the outermost loop. So it is again Vi minus Vc1 minus Vc3 plus Vc2 is equal to 0. Vi is equal to Vm. Here you can see this value is Vm. So Vi is Vm. Vc1 is also Vm minus Vc3 and Vc2 is equal to 2Vm. Vc2 is equal to 2Vm. Mind it that we have not taken it as the minus 2Vm because this minus sign we have already account for here by changing the polarity across this capacitor. So that is why instead of taking it as minus 2Vm, we are taking it as 2Vm, because if at all I write here minus 2Vm, that means we are making it plus, minus and minus plus 2 times. If you are taking minus sign, then it will become plus sign. So that is why always remember, once you have taken you have account for the sign in the circuit or in the KVL itself, then you just have to put the value, magnitude value. You need not to write sign in the second case. So now this will get cancelled. So Vc3 will be equal to 2Vm. Again, this is a positive value, so we will retain this sign, and Vc3 is equal to 2Vm. So if you measure the voltage between these two capacitors, so the net voltage will be equal to 3Vm. So this is how we can convert the any voltage doubler circuit to the tripler to the quadrupler by keep adding the one pair of diode and capacitor in the circuit. So similarly, we can make the diode. We can make the quadrupler circuit by connecting the 4 diode and 4 capacitors. this is the voltage quadrupler. So, VC1, VC2, VC3, VC4, D1, D2, D3 and D4. So, in the first half cycle, this capacitor, this will be equal to Vm with the sign plus and minus. In the second, it will be plus, this will be plus minus 2 Vm, this will be plus minus 2 Vm, so here this is up to this point, this is voltage tripler circuits. If you want to convert this as the voltage quadrupler, then we have added here a one pair of diode and capacitor in the circuit. So here when we measure the voltage between these two terminals, then it is 3 Vm. Now here we can see that during the time period T2 to T3 to T4, T3 to T4, this is minus and this is plus, and that is again Vm. So the effect of this Vm will get cancelled, and here we can see that this positive will make this diode reverse bias. Again this negative and this positive will make this diode reverse bias. Also this negative will make this diode reverse bias, but this negative will make the diode D4 as the forward bias. So this will be forward bias and all the three diodes will be in the reverse bias state. So now the current will be flowing in the outer loop, the most outer loop, and here again we kept the, due to this direction, initially I'll make this at the higher potential and this plate at the lower potential, and if we keep writing the KVL, then it will be during the time period T3 to T4, the KVL will be minus of Vm minus Vc1 minus Vc3 minus Vc4 plus Vc2 is equal to 0. So keeping that value minus Vm minus Vm, Vc3 is equal to 2 Vm minus Vc4 plus 2 Vm is equal to 0. So this minus will get cancelled and Vc4 is equal to minus of 2 Vm. So again here existing the minus sign, so we have to change the sign across this capacitor. We have to interchange this sign and the value comes out to be 2 Vm. So if we measure the voltage across these two capacitors, so we can see that the output voltage is equal to minus of 4 Vm. So the sign is negative, but the net voltage is 4 times of the peak input voltage which is appearing across the secondary of the transformer. So this is how we can always keep multiplying the output voltage of the keep multiplying voltage at the output or across the load resistance. So by using only a lower voltage step up transformer, we can get the multiple output voltage which is the DC voltage across the output resistance of any multiplier circuit. So, this is all about the voltage multiplier circuit. Jai Hind.